Oh yeah, this is a short screencast lesson on covalent bonding, again AQA topic 3. Here's a quick retrieval. Pause the video here and have a go. Okay, if we quickly have a look at this before we move on. What's an ionic bond? It's a bond between a metal and a non-metal ion. It's a bond between a positive ion and a negative ion. Opposite charges attract. How do elements remain in an ionic bond? They remain as ions. What ions do metals and non-metals make? Metals make positive ions, non-metals make negative ions. How many particles are there in 1 mole of any substance? It's 6 times 10 to the power of 23. And the name of this number is Avogadro's. Okay, so moving on. That's our objective. And we're going to try and draw covalent bonds. Look at this. Pause the video here. Compare the 3 diagrams of bonding. See if you can write something about A, B, and C. You can pause the video here. Okay, let's have a look. So, looking at A, you can clearly see there are charges. You can also see these 2 electrons have come from over here. So they've been donated. B, we can see you've got positive ions here. Okay, surrounded by negative subatomic particles, the electrons. And C, you can see in this case, the electrons are being shared. And the interesting bit in C is hydrogen is a non-metal and oxygen is a non-metal. Whereas in this one, where in A, magnesium is a metal and oxygen is a non-metal. Let's move on. Covalent bonds share electrons. So there's no like ionic bond where metals donate, non-metals accept. That doesn't happen here. Covalent bonds are where electrons are being shared. Covalent bonding occurs between non-metals only. So non-metals only, 2 oxygen atoms to make O2. A bond between hydrogen and a chlorine atom makes hydrogen chloride or hydrochloric acid. A bond between 2 hydrogen atoms and 1 oxygen atom makes water, and so on. You know, I suppose carbon dioxide. Carbon is a non-metal. 2 oxygen non-metals to make carbon dioxide. So these are all covalent bonded substances. Covalent bonds do not have charged particles, so there's no ions present in a covalent bonded substance. If we move on. What is the atomic number? Pause the video here. So let's have a look. What's the atomic number? Atomic number is the number of protons. But it can also be the number of electrons. Number 2, how many electrons will chlorine have in his outer shell? Well, chlorine is in group 7. This means it will have 7 electrons in the outer shell. And to work out its electronic structure, well, it has 17 electrons. So 2 will go in the first shell, followed by 8, followed by 7, totaling 17 electrons. Moving on. What you see here is you see a chlorine atom here, 2 electrons in the outer shell, 2, 8, 7. It's got 7 electrons in the outer shell. And the magic number it's trying to achieve is, well, it's trying to fill its outer shell. And to fill the outer shell, it wants 8 electrons, but it only has 7. If we move on to this chlorine atom now, this also has 2, 8, 7. So this one is one short also. In fact, both chlorine atoms are one electron short. So what they do then, they will then form an area where the electrons are being shared. And what you see then is if we look at this chlorine, it's got access to 8 electrons in the outer shell. 1, 2, 3, 4, 5, 6, and 2 in the middle. And if we look at this chlorine atom, it's got 1, 2, 3, 4, 5, 6, and 2 in the middle again. So 8. So they both have now full outer shell. So what you do find is this is the chlorine molecule. Chlorine is diatomic. Diatomic meaning 2 atoms. All halogens, in fact, are diatomic. So fluorine gas is going to be that. Chlorine, you already know. Bromine, Br2. Iodine, I2. Hydrogen is also diatomic, H2. Oxygen, O2. Nitrogen, N2, and so on. Now, two ways you can draw this in the exam. You can draw it like this one, where you can show all the shells, or you can draw it like this one, where you only need to show the outer shell. Which one would you prefer, or which one do you think the examiners will prefer? It's best to draw this one. Okay, just the outer shell. Now, the way to represent chlorine, so there's your chlorine molecule. You can represent it like this, or like this, or like this. And what you will find is that little dash represents a single covalent bond, and it's made up of 2 electrons. How many electrons? If you look at oxygen, that's oxygen. So that is a double covalent bond. So how many electrons will you find in a double bond? The answer you should have got is 4 electrons. Here you go. You can see that. So hydrogen and chlorine make hydrochloric acid, and that is a single covalent bond. So 1 electron each, one from hydrogen, 1 from chlorine, and they're sharing 2 electrons. Here, double bond. So oxygen, 2 electrons from this oxygen, 2 electrons from this oxygen, total 4 electrons, which is a double bond. Examples are H2, Cl2, O2, hydrogen chloride, H2O, ammonia, and methane. These are all covalent bond because these are all non-metals. When a simple covalent, and this is a key word, when a simple covalent structure melts or boils, the weak intermolecular forces are broken. Simple covalent bond structures have a low melting point, and the reason why they have a low melting point is because it's easy to break the weak intermolecular forces. The intermolecular forces increase with the size of the molecules. So the larger the molecules have, the higher the melting and boiling point. So make a note of that. And then these substances do not conduct electricity because the molecules do not have an overall electrical charge. Don't forget, covalent bonded substances do not have ions. You can pause the video here. You can have a go at these questions. And what you will find is hydrogen. So if we look at hydrogen, will be a single covalent bond. Chlorine, again, will be a single covalent bond. Oxygen will be a double covalent bond. Hydrochloric acid, single covalent bond. Water, what you will find is like this. 2 hydrogen atoms, 1 oxygen atom. Ammonia, you'll find 3 hydrogen atoms, but there'll be because 2 electrons there. And then methane will be surrounded by 4 hydrogens, all single covalent bonds. And when it says name the hydrocarbon above, well, this is the hydrocarbon. And like we've just said, it's methane. Hydrocarbon is a compound containing the elements carbon and hydrogen. And then draw a dot and cross diagram for carbon dioxide. If you draw a dot and cross diagram, you should end up with something looking like this. So you've got carbon, double bond oxygen, double bond oxygen. That's carbon dioxide. Moving on. Here's some exam questions for you. The diagram represents molecules of hydrogen and chlorine. Draw a similar diagram to represent a molecule of hydrogen chloride. You need to show only the outer energy levels. So pause the video in when you're ready. And what you should find there. So there's your single covalent bond. If we move on. The word equation is hydrogen plus chlorine gives you hydrogen chloride. Write a balanced symbol equation for 2 marks. And the next question for 1 mark, hydrogen chloride gas reacts with magnesium to form an ionic compound called magnesium chloride. You need to find out the formula for magnesium chloride. So pause the video here. Okay, so what you have got, there's your balanced equation, and there's the formula for magnesium chloride. Think about it, magnesium is Mg2 plus, chloride is Cl minus, so that 2, that invisible 1, and you end up with MgCl2. Moving on. Pause the video here, have a go at these 2 questions. What you should find, we'll move on. There's your 2 mark. Why does magnesium chloride have a higher melting point than hydrogen chloride? Because magnesium chloride is made of ions. Hydrogen chloride is made of molecules or is covalent. And moving on, next one. So this one, question 2, it's worth quite a few marks. And it does say included description of bonding and structure of chlorine and sodium chloride in your answer. And this is what the examiners are looking for. If it's just a simple statement, then you can't get more than 2 marks. If there are statements about bonding and the structure of chlorine, then you're looking at marks between 3 and 4. But if you give a full answer, a statement about bonding, the structure of chlorine and the structure of sodium chloride, then you've got possible chance of getting 5 to 6 marks. And these are what they're looking for. Examples. Okay? And that's the end of this screencast.